Okay, let's look at section 1.2 subsets. All right, so let's talk about subset. So here's the notation. We say set A is a subset of set B. All right, so this is defined as for all, here's my lazy notation. So this means for all. Right, for all elements, say x, in, here, remember this is notation, in set A. So whenever I pick an element from A, then that element is always in B as well, right? So A is a subset of B if every single element in A is also in B, right? So if you visualize a set, let's say you have a set B. So let's say this is your set B, right? And the set A is going to be sitting entirely inside B, right? So that's what the subset is. All right. Then equality. Equality. So for notation is of course set A is equal to set B, right? And you can define equality using subset, right? A equals B if and only if A is a subset of B. At the same time, B is a subset of A, right? So when you have a mutual containment, the only way this can happen is that both A and B are exactly the same set. All right, and there is something called the proper subset. So not just subset, the proper subset. Proper subset, it means that, so when you say A is a subset of B, right? If, right, this means that A, of course, A have to be a subset of B. And also, A is not the same set as B, right? So if it's a strictly smaller set, so sitting inside, then we say it's a proper subset. So A is a proper subset of B, right? And the last one is called the power set. Power set is really the set of all possible subsets. All right. For example, all right. So let's say we have this funky set A. So A has three elements, and 1 is the first element, and the second element itself is a set. So it's an empty set is the second element. Third element is a set with 1 in it. All right. So A has three elements. So if you want to see the cardinality of A, it's definitely 3. Okay. And when you want to find the power set, so you have this power set. So it's a cursive P of A. All right. All right. So this is going to be the set that contains all possible subsets. All right. So first subset, smallest subset is an empty set. Empty set is an always a subset, right? That has no element. And a subset with the only one element would be, okay, you can have a set with 1 in it, right? That will be a subset of this. Or set with empty set in it, that will be a subset of this, right? Or set with 1 in it, that would be the third element, yeah, here, right? Or we can have a subset with 2 elements, so you could have 1 and empty set, so that would be a subset. Or we can have 1 and set with 1 in it, right? So actually I have to make this guy a little bit bigger. Or we could have a set with empty set and a set with 1 in it, right? Or we could have a subset which has all 3 elements, so which is the same thing as A. Maybe I'll write A here, right? This is called power set. You can see that it contains all possible subsets of A, right? Then the one thing you might want to know is the number of cardinality of power set. It's fairly easy to find. So you have a power set here, and the cardinality of power set is always 2 to the cardinality of A, which is 2 to the third power, which is 8, right? Let's see, let's count it. 1, 2, 3, 4, 5, 6, 7, 8. So this is the power set, which has all 8 elements, right? So just remember that the power set is simply the set of all possible subset, and empty set is always the first one, and the last one is always the set itself, right? That's it. I hope that this was clear.